I would like to share our experience in our center, IBCC Oncologia, and Articon Group using the SunCHECK platform. So, a quality assurance program, we know that it's made up of an extensive list of tests with their tolerance and frequencies, and we have a bunch of devices like phantoms and detectors, different detectors. But I would like to emphasize that another component, the last but not least, it's that the physicists need to choose a data recording and analysis system. So, and these are traditional made by spreadsheets and paper forms. The periodic tests that we made in a QA program is necessary to monitor the equipment performance is an important aspect of the quality assurance program. There are excellent publications. Many of them is reviewed constantly. So the main one that we choose to create our QA program is to TG 198 that is published in 2009 to 2021. And another one that is recently published is the MPPG 9B, that it's an excellent complement of the TG for the radiosurgery and the stereotactic treatment. So all of them, we have the tables that is excellent reference for us. We know that the increasing complexity in the linear accelerators, the number of periodic tests has been increasing significantly too. And consequently, the workload of the medical physicists done to analyze and collect the data. So the TG198 document estimates time for each test. It's a different sections in this TG. It's interesting to consult. And for accelerator, for a monthly test, just for basic parameters of the accelerator, it's estimated that 4 to 5 hours checking the parameters without considering the EDW, MLC, and imaging system. And for annual tests, it's 40 to 60 hours. So as TG highlights, it's important to consider a commercially available software. This is an important ally for us to search for the operational efficiency. So I will talk about the SunCHECK machine. It's a part of the SunCHECK platform. So we talk about this part. It's not related to SunCHECK patients. Here is the main characteristic of our center that is located in São Paulo, in Brazil. It's a single institution, a single location, treating 1,500 patients per year. Here is a 100% variant environment, and we have the 3 linear accelerators, 1 brachytherapy, and we did all of the high technology, treatment techniques in our department. And we are a Sun Nuclear reference site too, and we have these solutions from the company. In our, I will talk about our experience in validation and the implementation phase of the SunCHECK machine. It's interesting because it's a platform, it's a browser-based platform, and it's allowed to use nowadays you use for periodic tests for daily, monthly, and yearly tests for all of the machines for LINAC, HDR, and CT. So we have all of the machines controlled by the software. And our implementation phase is related to we use the validations of the platform because it's a software and we need to be careful about the results and all of the things. So we did a simultaneous collection with the paper forms and the spreadsheet too. And the important aspect of the implementation phase is the acquisition of the baselines. So STG highlights for us, be careful with the baselines. It's an important aspect. So we need to consider time and efforts enough to precision acquisition of the baseline. That is the main aspect of the use of the software. And I would like to recommend to consider the MPPG 8B. That's a recent publications that have an excellent discussion about the reference data for QA. So it's another important publication to consult to baseline acquisitions. Here is the rough timeline of our gradual implementation steps. That was not so fast as we expected because of high clinical demands that we have in this period and the pandemic period. It's a challenge for a lot of radiotherapy department. So we choose to use a step-by-step implementation gradually for each functionality of the system. So I would like to show the transformation of the platform give us in our QA program, showing how we done the test before the SunCHECK platform and how they start to be done. Here we start with the image system, the CON-BCT. Here is our previous form with the manual collections and analysis. After the introduction of the software and the use of this specific phantom, the analysis was very fast and automated. Maybe it's one of the most expressive again of time when I've spent time is this test for CON-BCT, in my opinion. There are traffic lights to compare the result with the tolerance. And when the image is acquired in the accelerator in the LINAC, the SunCHECK server automatically through the query system pulls the image to the platform and performs the analysis. So it's not necessarily the import-export step. Another important test for us is the picket fence test that we use for the MLC. Here is the method using film and analysis was performed visually. This is the test, it's a hidden test that we did, and the precision of this test by using the visual analysis is 0.5 millimeters. Sorry, 0.5 centimeters. And so with the platform, when you use the platform, this precision is more robust. So we can carry out precision of the 0.1 millimeter with the indications of the pairs that failed. It's important that TG, I would like to highlight for everyone that TG recommends this test do in the frequency weekly. So we need to and varying the gain through angles too. So it's our program. We did this test in weekly, and we varying for cardinal angles in linear accelerator. When we often looking for sub-millimeter precision in the various parameters in LINAC, in radiotherapy. To illustrate the clinical importance of the quality control, one of the most important components of a LINAC is the multi-leaf. Okay, so the publications, classical publications from Los Tassos show us that even sub-millimeter errors can lead to those errors of 5 to 10% or more. So it's very critical, this parameter. And another recent publications show the effect of the variation up to 1 millimeter in the IMRT and VMAT cases, and conclude that deviations up to 10% can occur on target or organ risk. So therefore, the lack of quality control tests can lead to undesirable clinical effects on the patient. Here I'm showing our preliminary results of analysis that we do in our department that we are developing to compare the efficiency and sensibility of different methods of picket fence analysis. So we compare the four ways of do this analysis: the visual only, the visual plus profile analysis, the gamma passing rate, and the SunCHECK platform. So we are using 5 tests, 4 of them with the introduced errors, And here are the time spent to perform the analysis. So we can see that just to okay. So we can see here that we save a bunch of time that when you use the SunCHECK just for one single test. We can remember that this test is important to do weekly. So we plan to do it more robust way to do blindly to another colleagues to analyze and to test the sensibility of the analysis comparing this method to another test that's important, especially for the stereotactic treatments, it's Whiston Lutz. Here we can see a traditional way to do this test using by film. It's quite noisy and difficult to quantify this test. So the platform bring us the opportunity to quantify more objectively the diameter of our isocenter. That's important to estimate the margins for PTV for these small lesions, for example. Another widely used test to analyze the isocenter of the gantry and collimator and couch separately is the star shot. Once again, their analysis without the use of software is quite subjective and limited. With software, highlighting is tracked by a detection. You can see here, detection algorithm more accurate than the human eye.